Section 1.2, Use Segments and Congruence. In this section we're going to talk about two postulates. A postulate is also called an axiom, and all that is, it's a rule that is accepted without being proven. Okay, so it's a rule that hasn't been proved, but everybody accepts that that's the way it is. That's what a postulate is. When we start proving these rules, then we call them theorems, and we'll get into those later in the chapter. So our first postulate, postulate 1, is called the ruler postulate, and it says that points on a line can be matched 1-to-1 with real numbers, and these numbers are called coordinates. So if you have a line with points on it, we can assign numbers to each of those points. Okay, one thing that we use, that you use on occasion that already do this for us, is a ruler or a tape measure. It's like a number line that assigns numbers to each of those points that are on that ruler or that are on the tape measure. So these numbers then are called coordinates. And in Algebra 1 we talked about coordinates being on a coordinate plane or a number line. Those were the number values that were associated on those planes or those number lines. And that's all they are here. They're just the numbers assigned to points that are on a line. Okay, to go along with this, we know that the distance between point A and B, written as AB, notice there aren't any markings above the A and the B. That tells us that this is a length. So it's going to be a distance between A and B, is the absolute value of the difference of the coordinates of A and B. And the reason we want to use absolute value for distance is distance can only be positive. So because distance is only positive, we have to make sure our answer is a positive answer, and to do that we can use absolute value. So to find the distance between these 2 points, we just have to subtract their coordinates or the number values that are assigned to them, and then take the absolute value of that difference. So it doesn't matter if these numbers are positive and negative. Once we do the subtraction, if it turns out to be a negative number, then we change it to a positive because of the absolute value. So that's why we have to use absolute value. Okay, so let's look at an example. So we have this line segment up here from S to T, and we want to find the distance of this, or the length of this line segment, in centimeters. So I'm going to take my ruler on the centimeter side. There's a couple of ways we can do this. You could start at 0 and then just move over, and you can see that it's 5 centimeters. Okay, and the way the formula would work then, if you started at 0, this at 0 and this at 5, then we would say that the distance from S to T would equal the absolute value of 5 minus 0, which is equal to a positive 5. Now you don't have to start at 0. We could have started at, say, 3 and ended at 8. So instead of 0 and 5, if I would have started at 3 and ended at 8, I still could have found the same value. The distance would be 8 minus 3, which we know is 5, and the absolute value of 5 is still 5. So we get the same distance no matter where we start on our ruler. If we were to subtract these separately, instead of having this number first and the 3, we could also do it that way. And this is why we need the absolute value signs, because 3 minus 8 is negative 5, but the absolute value of negative 5 is a positive 5. So we still end up with the same value, and that's why they use the absolute value when you're finding distance between 2 points, is because we always want it to come out positive. All right, the second postulate that we're talking about here in this section is postulate 2. And it says if B is between A and C, then segment AB, the length of segment AB plus the length of segment BC is equal to the length of segment AC. This also works conversely. If the length of segment AB plus the length of segment BC is equal to the length of segment AC, then B has to be between A and C. I kind of messed up, so I threw that in there. All right, so it works both directions. So all we're saying here then is if we have a segment from A to C and B is between there, that the distance, this length AC, is the same as AB distance plus BC distance. We add these two together, it's going to equal that entire length up there. So it's a pretty easy concept to understand. Okay, the last part of this section deals with congruency. Line segments that are the same length are called congruent segments. Okay, line segments that are the same length are called congruent segments. We don't necessarily know what those lengths are, but we just know that they're the same. So right here I have segment AB and I have segment CD, and those two are the same. That's what those little marks mean. If I have a single mark in both of them, it means that this segment is congruent to this segment here, which also tells me that the length of AB, whatever it is, has to equal the length of CD. Remember, when there's no mark above it, we're talking about length here. And then back to our congruent statement, it also means that segment AB is congruent to segment CD. So both of these things are true when these segments are congruent. The lengths have to be the same, and of course then the segments are also congruent to each other.